Factor by grouping is used on 4-term polynomials. Factor by grouping is only used, very specific, it is only used in 4-term polynomials. What we've been doing beforehand, the unfoil and the ungrid, right? Xbox and foiling, those have only been used on what kind of polynomials? What specific type of polynomials have we been working with? Not binomials. Our answer is a binomial times a binomial, but our original problem is what kind of polynomial? A trinomial. So we're going away from a 3-term polynomial. Every single problem we have today will have 4 terms in it. It will be a 4-term polynomial. So in order to factor by grouping, the first thing we always look for is the leading coefficient negative. No matter what our polynomial looks like, we always have to look and see, is the leading coefficient negative? Because if the leading coefficient is negative, we have to remove that negative from everything, right? We have to take the negative out and change everything behind it, because we cannot factor if our leading coefficient is negative. Just the way that it works. So you either say, yes, there is a leading negative coefficient, and we factor that out, or you say no and move on. After we look to see is the leading coefficient negative, we say, is there a GCF? Because that greatest common factor is going to make our lives a whole lot easier if we take it out now instead of worrying about it later. Is there a GCF? Because if there is a greatest common factor, get rid of it first. Who wants to work with the number 75 if you can divide it by 5 and make it smaller and work with 20, right? Like, I mean, these are the things that we think about. Where your greatest common factor is 3 from everything, right? And we automatically take these things down. Greatest common factor. After we've done these 2 steps that we always do for everything, then we get into the factoring of the polynomial. So we split it in half. If it's a 4-term polynomial, how many will be in the first half and how many will be in the second half? 2 and 2. Just like a binomial times a binomial, right? Which is what we've been doing this whole time. So we split it in half. And we factor the GCF for each half. We factor the GCF for each half. So we have this 4-term polynomial. I split it in half, meaning I got 2 in front and 2 in back. I look at the first 2 and I find their GCF. I look at the last 2 and I find their GCF. So we're splitting it in half and factoring each part separately for a greatest common factor. Lily, put them away. The leftovers should match. The leftovers should match. When you take the GCF out of the first 2, what's left behind should match when you take the GCF out of the second 2. The leftovers should match. And then we just have to write our solution. Our solution looks like GCF plus GCF and the leftovers. So it's used on 4-term polynomials. If you have 5 term polynomial, we can't do this. We just do the first two steps, leading coefficient and greatest common factor, and then we're done. If it's a 4-term polynomial, 4 terms, 4 individual separate terms, this is what we do. Are you ready to practice?
No.
Yes, you are. Don't lie. You'd rather take more notes?
Yes.
Liars.
What to do?
Here we go. Five x to the third minus 4x squared minus 3x plus 24. It is a 4-term polynomial. Each term is separate, right? There's no like terms that can be combined. I've got an x to the third, I've got an x squared, I've got an x, and I've got a constant. They're all separate, so they cannot be put together. Chris, put your marker away right now, please. First question, is the leading coefficient negative? What is the leading coefficient? Positive 5. So is it negative? Skip step number 1. Is there a greatest common factor? So let's look. Can 5, negative 4, negative 30, and 24, do they have a greatest common factor? Can they all be divided by the same value? No, their greatest common factor is 1, so not worth it. 3, split the polynomial in half. Where am I going to draw my halvesies line? Yes, right here, because that minus sign belongs to that 30. Do you agree? Okay. Step number 4, factor the GCF for each half. Factor the GCF for each half. 5x to the third minus 4x squared. What do they both share? What is the GCF, the greatest common factor, of 5x to the third minus 4x squared? Jacob?
X squared.
X squared. Perfect. Five x to the third divided by x squared is what? What's left over? 5x. We're factoring out our greatest common factor. And negative 4x squared divided by x squared, what's left over? Negative 4. All right. Factor the GCF for each half. So I did the first half. Now let's do the second half. What do negative 30x and 24 have in common? Negative 30x and 24, what do they have in common? Negative 30x and 24, what can they both be divided by, Ariana?
3.
More than 3. 6, but hold your horses, ladies and gentlemen. In this second half, what do you notice? My leading coefficient is negative. So I'm not factoring out a 6, I'm factoring out a negative 6. And here's the hint of why we're going to go with 5 or with 6 instead of 3. My leftovers should match. I want to get this piece right here to be 5x. My leftovers should match. Right here, the leftovers should match. I want to make this negative 30x. I want to find a greatest common factor that my leftover is going to be 5x. And is my leftover 5x? Negative 30x divided by negative 6 is 5x. And 24 divided by negative 6 is negative 4. My leftovers should match. Because once my leftovers match, I write my solution, which is GCF plus GCF, x squared minus 6. And then the leftovers, which is 5x minus 4. Let's try another one. 35b to the third minus 30b squared plus 14b minus 12. We have questions that we need to ask before we start doing anything. The first question we should always ask every single time is the leading coefficient negative? What is my leading coefficient? 35, which is not a negative number, so I don't have to do anything. My leading coefficient is positive, so I'm good to go. Second question, is there a greatest common factor? So before we start, let's check. Let's make our numbers smaller if we can. Do 35, 30, oh, I guess I should say 35b to the third, because maybe there is a greatest common factor of a variable, right? Negative 30b squared, 14b, and negative 12. Can they all be divided by something? Factors of 35, 5 and 7, correct? 30, can they be divided by 5 and 7? Can be divided by 5. 14, can it be divided by 5?
Nope.
So I don't have a greatest common factor. Step 3, split the polynomial in half. Where does it go? In front of that plus sign? Okay. Four, factor out the greatest common factor for each half. 35b to the third minus 30b squared. What can they both be divided by? What's their greatest common factor?
5b squared.
5 what?
B squared.
B squared, yeah. $35b to the third divided by 5b squared leaves behind what? 7b. Minus 30b squared, negative 30b squared, divided by 5b squared leaves behind negative 6. Factor out the greatest common factor of the second half, 14b minus 12. What do 14b and negative 12, what can they both be divided by?
2.
Or you can think to yourself, how do I make this 14b become 7b? Right? Because you want your leftovers to match. I want my leftover to be 7b. That tells me I need to divide by 2, which is the greatest common factor. And negative 12 divided by 2 is negative 6, making the solution what? You can do it. What's the answer? Plus 2, because it's positive 2, yes. 7b minus 6. We have 2 more practice problems. Really 3, but you'll be okay. All right. You're going to work them out. See what you can do. Oops, I wrote this one wrong. It's okay. Nope. We'll do it in the next one. There's practice problem number 1. Follow your steps. Is the leading coefficient negative? Is there a greatest common factor? Split it in half. Factor each half. Write your solution. Follow those 5 steps. 35x to the third plus 245x squared minus 49x minus 343. Here's a hint. You've got really big numbers. Do you agree?
Yes.
our factor squares don't go up to 343. I would guess there might be a greatest common factor. And you say to yourself, but Mrs. Long, this isn't fair. I don't know the factors of 245. You're right, but you do know the factors of 35. The greatest common factor has to be one of those numbers that 35 is divisible by. You do know the factors of 49. Maybe you could look and see what's the greatest common factor of 35 and 49, because I can do those. And then the greatest common factor of those two numbers, let's guess and check. Let's get out my calculator and see, is that number also a greatest common factor of 245 or and 343? Have a calculator in your hand to see if those values can be divided by the same number. Again, I suggest you look and see greatest common factor between 35 and 49. I can do those two values. What can 35 and 49 both be divided by? This is their greatest common factor. Now let's take a calculator and check. Can those other two values be divided by that number? Question number 1, is there a greatest common factor, or no. Question number 1, is the leading coefficient negative?
No.
No, so I can skip that and move on. Question 2, is there a greatest common factor? The answer is yes. There is a greatest common factor. The greatest common factor, if I look at 35 and 49, the greatest common factor between 35 and 49 is 7. So I need to now check, can 245 be divisible by 7? And is 343 divisible by 7? So the greatest common factor is 7. If you want to draw it like this with 7 underneath it, that's perfect. I have 7. What's 35x to the third divided by 7? What is left over? 5x to the third. 245x squared divided by 7 is much more manageable. Negative 49x divided by 7 is, and negative 343 divided by 7 is, so step number 1 didn't have to worry about because there was not a leading coefficient that was negative. Step number 2, greatest common factor, the answer was yes. I found one. Step number 3, split the polynomial in halvesies, right there. Right? Step number 4, factor each half. What do 5x to the third and 35x squared share? What do they have in common? 5x squared. Leaving behind x plus 7. Looking at the second half, what do negative 7x and negative 49 share? A negative 7, because my leading coefficient is negative. I have to take that negative out. Leaving behind what? X plus 7. They match. I've been successful. If they didn't match, what do you think we would do? If they didn't match, if I had x plus 7 and I had 2x minus 8, they didn't match, what do you think your answer would be? Unfactorable. Unless there was a greatest common factor, right? But if you split it in half and you cannot get your leftovers to match, you're done. What's my solution? 5x squared minus 7. Okay, 5x squared minus 7 and x plus 7. Now I'll tell you this, if you wrote that down, I'd mark it wrong. Don't forget that GCF of 7. Don't forget. Try this one. I have to make something up because I messed that one up. Hold on, mental math is hard. 3. Oh, don't say it out loud. This is long. Negative 6x to the third minus 3x squared plus 8x plus 4. All right, first question, is the leading coefficient negative?
Yes.
It is, so let's fix it. The leading coefficient is negative, so if I take that -1 out, what does my new problem look like? Everything changes, so negative 6x to the third becomes positive 6x to the third, minus 3x squared becomes plus 3x squared, plus 8x becomes minus 8x, and 4 plus 4 becomes excellent. Question 1, is the leading coefficient negative? The answer was yes. Question 2, is there a greatest common factor? No, 6 and 3 have a greatest common factor. 8 and 4, but they all don't share one. Question 3, or step 3, split it in half, right there. Step 4, factor the first two. What do 6x to the third and 3x squared, what do they share? Leaving behind what? 2x plus 1. And the second half, negative 8x minus 4, what do they share? Leaving behind 2x plus 1. Last but not least, what's my solution? There. Keep going.
Parentheses 3x squared, negative 4, parentheses 2x plus 1.
She remembered that beginning step where we factored out that negative leading coefficient. Remember, that was our downfall last time. All right, we're doing one more. I want to show you so you can start looking for it. So x. Okay, last one. Two x to the third minus 3x squared minus 32x plus 48. Question 1, is the leading coefficient negative? Nope, it's positive. Question 2, is there a greatest common factor? No. Question 3, or step 3, I guess not really a question. Step 3, split it in half. Don't forget that minus sign belongs to the negative 32x. 4, factor the first half. What do 2x to the third minus 3x squared, what do they share?
1x².
They share an x squared. Leaving behind what? 2x minus 3. What do negative 32x and 48 share? What is the greatest common factor? Negative 32x and 48. Or you can think to yourself, how do I make negative 32x become 2x? What can I factor out? What can I divide negative 32x by to get a result of positive 2? Negative 16. Because negative 32 divided by negative 16 leaves behind positive 2x. And 48 divided by negative 16 is negative 3. My leftovers match, so I factored correctly. If my leftovers did not match, what would my answer be? No solution, unfactorable, we're done. The original problem is my answer. It cannot be factored. However, this problem, ladies and gentlemen, is not done, because what we also need to start thinking about and looking at is this guy right here. Because there's an x squared still here. There's an x squared here. And there's an x squared here. But I cannot split apart 5x squared. Because 5 is not a perfect number, right? But down here, I have 2 perfect squares. How do you get x? What times what equals x squared? X times x. And what times what equals negative 16? No.
Negative 4 and 4.
Negative 4 and positive 4. It only works with a subtraction, so they're called the difference of 2 perfect squares. It only, if this said plus 16, we'd be done. But since it says minus 16, I know that I can split it even further. I can do x plus 4 and x minus 4 and 2x minus 3. So you have to start being on the lookout for the difference of 2 perfect squares. If it says x squared minus 9, you can factor that further. X squared minus 9 can be factored because 9 is perfect, correct? If it said x squared minus 25, it could be factored further because 25 is perfect. But if it said x squared minus 30, could you do it?
No.
Because 30 is not perfect. If it said x squared plus 100, 100 is perfect, but it's not a minus problem. It has to be x squared minus a perfect number. Could you do it if it said 2x squared? How do you get 2x squared? Here's 1x and 1x. That doesn't equal 2x squared. How do you get 2x squared? 2x and 1x. So is that perfect? Are they the same? No. So if there's a coefficient to this x squared, what does the coefficient have to be? It also has to be perfect. If there isn't a coefficient, then we're fine, right? You have to start looking for the difference of squares. They're hidden places. Questions?